Hi, everyone. Thanks for coming. Happy to see quite a full room for something I thought maybe was quite a niche topic. So super happy to see there's so much interest for it in such a tech hub. Let's see if this works. Yes, this works. Great. So what I want to talk about today is design thinking for artificial intelligence, and you'll grow to figure out what exactly I mean by that as we go along. First, I would love to know, like, sort of who's in the room, like, who am I speaking to? So I'd like to see sort of a show of hands in which category you would put yourself. So who considers themselves a developer, engineer, or... OK, cool. Thanks for coming. Super happy you're here. Super happy to hear your thoughts afterwards as well from a tech perspective. Designers, creatives. Yay! Nice. Like people in product managers. Nice. And entrepreneurs, founders. Wow, it's such a perfectly equal distribution curve over all the different roles. Nice. OK, so I won't target to anyone then. Great. And then I'm curious, who's heard of design thinking? OK, and who of you keep your hand up if you've actually worked with it or you've practiced it in your work? Amazing. Shout out. And how about AI, machine learning, data science, advanced statistics, whatever? Wow, amazing. OK, well, super happy. There's actually so many AI people in the room. So this one, it's very much about building a bridge kind of between the discipline of machine learning and kind of everyone else. So I think it will be equally valuable sort of for both sides to see different angles to the problem. So now that I know a little bit about who you are, I'll introduce myself quickly. So my name is Nadia Piet. I was born in New Zealand. I grew up in the Netherlands, and then I've been kind of moving all around the globe since I was 18. And I decided that, well, I figured out that you can go freelance if you know how to build websites, and you can be 18 years old and travel around the world and build websites for whoever needs one. And so I thought that was a great life hack, and I just sort of went with that. And then I've been going through, lots of different roles, always very much at an intersection of design, tech, and business. So now I've settled on sort of strategic and surface design, which is, approaching non-product things, non-necessarily like a table or a phone, non-tangible things with a design mindset to solve complex problems and create useful things for people. So that's kind of what I do now, and I'm really interested in technology and most recently more like AI and machine learning and what that's gonna mean. And about building or designing preferable futures. So a lot of people think about the future as this thing that's coming, whereas I see it much more as a thing we're shaping. And so that's something I really care about, sort of democratizing technology with a design approach and seeing if we can, build a good world and products and services from that. So we shape our tools, and then our tools shape us. And as you see, I've been phenomenally shaped by the computer. This is me at 10 years old, and this is me at 26. And it's basically just always me and my computer. And I love it that way. So, cute emoji change. So I'm going to start with a crash course to AI machine learning. So a lot of you actually have experience. So bear with me with some of the simplicity of this. And for everyone who hasn't worked with AI or machine learning or just has these crazy robotic Skynet images in their head, this will be a great sort of 5-minute primer on what it actually is and how it works. So in general, it is the super vague and broad notion of teaching machines to do things that we traditionally think of as human tasks or human abilities. Very vague definition, but that's, as specific as it gets, actually. And then there's a big difference between artificial intelligence and machine learning, which I'd like to distinguish, because the talk is called AI, but actually, none of this stuff is about AI, it's about machine learning. So I wanted to point out the difference, which is, in really short, that artificial intelligence is the goal. So it's this very broad aspiration of making machines do things, like you said, that we think of as human activities. But how we actually do that, the sort of verb of making that happen, currently is machine learning. So we might find other ways of making that happen as well. But currently, sort of all the functionalities we're seeing, they're coming from machine learning and deep learning. So I'd prefer to refer to that because it's a bit more specific and descriptive. So artificial intelligence is the goal. So it doesn't actually do anything. It's just this very far away horizon. And machine learning is actually our steps towards that horizon. So it's a verb versus like a vague notion. So machine learning, still quite a vague term. So in really short, it means, or how it's different from programming, I think is quite helpful to point out. So basically in traditional programming, how you communicate with the computer is you give it data and you give it rules and you're like, do these things to this data to create this output, right? Whether you're building a website or you're saving something in a database or anything on your computer, it runs on these instructions, basically. Machine learning, on the other hand, it works through the data you put in and the output you want, and it figures out the rules or the instructions on how to get that output from the input, the data, by itself. So there's a lot of benefits to this, because if you don't know the rules, which, this world is a very complex place, to define rules about how things work and how things happen is sometimes a lot more complex. Which has really limited us sometimes in what we're able to do with computers and how we're able to communicate with them and how they're able to understand our world. So by them deriving their own rules and instructions, sometimes even in a way that we don't understand, is a whole new way of communicating. So why is this useful? I love to use this example because it's funny. So this is like a whole series. So machine learning engineers have a great sense of humor, I think. So this is, something they were training for computer vision. And it's basically trying to, teach the machine to distinguish between a labradoodle and a fried chicken. And to us, this seems really obvious. We're like, yes, of course, this is edible, and this is something I want to cuddle. But if you're trying to explain why in rules or like in texture or color or shape or size, like if you're trying to define the features, it's actually really, really hard to explain why this one is a chicken and this one is a cute little creature. So yeah, this is one silly example, obviously, but it's an example of how it can be useful. So in really short, it's a new way, like machine learning, it's a new way of communicating with computers, or like with all things, digital. You show examples and you give it objectives, and then it figures out the rules or the instructions. It's generally able to detect, predict, and generate. Answers come in probability scores, and yeah, we get to that later. There is some complications to this, like it might interpret the world in a way that is not necessarily incorrect, but just doesn't fit with the way us humans experience it, which is not rational and not computational and not mathematic, right? We are very fuzzy, subjective little creatures. So yeah, there's lots of complications to that, but in really short, that's machine learning. So this is a quote I think that's quite useful. Like, AI shines in problems where the goals are understood, but the means aren't. Like, we are clear on what the proper label for this image would be, but we can't quite explain to you how we would arrive at that conclusion. So whenever those kind of problems show up, usually machine learning might be helpful. So how does this sort of work? Ridiculously simplified, okay? Engineers, really sorry. But basically, you take training data. So in the example of the labradoodle, you would take like 10,000 pictures of the labradoodles, 10,000 pictures of the fried chicken. You label them and tell the machine, like, these are labradoodles and these are fried chicken. Look at them. It's very much like training maybe a baby or a child as well. Like, this is this, this is this. You can use different algorithms. You can try different algorithms to see which ones produce the best results. Then you do training, and then basically it creates a predictive model, and that one you can test. So now you can feed it a new picture, which we call testing data. So these are images of chicken or labradoodle it has not seen before. You show the picture, you're like, okay, you've been practicing. Is this a fried chicken or a labradoodle? And then you do this with a few hundred or thousand or 10,000 of images, and you kind of measure the accuracy of your model. If it's bad, you try again. You need a new set of training data and stuff, and you try it with different algorithms or different parameters, and you just keep. Machine learning, like design thinking, is very iterative, so you just keep trying and like tweaking stuff and tweaking your model until a better score comes out. And once it does, and you have the thumbs up, you can design and deploy your application. Then it continues to train sort of in the wild. So you deploy your application when it's at a decent accuracy, but then it continues to train when it's being used by your users. So you're feeding the data, you build the model. Now you're serving whatever your model is predicting in an interface to your user, whatever that is. And then based on their action or their response to that prediction, your model is going to learn whether it's a good or a bad prediction, and it just keeps feeding and trying and learning again and again. So that's how it then learns. I've used some of these terms, like data, algorithm, GPU, not yet, but yeah, training, model, prediction. I'm going to show an incredibly simplified metaphor, as most metaphors are, but I think it's still useful. So if you need to build a sort of like conceptual model in your head of how this works, and you're not, a computational thinker, let's say, I kind of like to think of it as this, where maybe you're cooking, and so algorithms are sometimes compared to, recipes. It's like a set of instructions that you follow to produce a certain outcome. So in that sense, we could compare, data to ingredients, the algorithm to a recipe, GPU to utensils like your baking tray and your oven and your that stuff. Training with practice, the model, which is kind of like the system, or the agent with the chef, like that is actually taking all this stuff in and doing some sort of logic to it and creating an output. And then the output is a prediction, but in our case, it's a cake. So yeah. This is different ways that machine learning learns. So there is supervised learning, which is sort of currently the most applied one. So that's the one I was describing before, where you show, you show the data, you say what the data is, and then you try, you see if it can reproduce sort of those results. You also have unsupervised learning, where your data is not organized and not labeled, or not as much, and you just kind of like feed it a bunch of data and ask it to kind of cluster it or make, derive some sort of patterns from it. And then there's reinforcement learning, which is much more like trial and error. So this is, for example, I don't know if you guys know, like AlphaGo, or like any sort of game learning, or things like Roomba or something. They work this way, where they have an objective, say, win the game with the highest score possible. These are the parameters of the game. Play it 1,000,000 times and, figure it out. This, obviously, you can only do if it's like a super controlled environment. Otherwise, there's some very real implications to that. And these are the three really common machine learning types. So regression is about like predicting numerical value, sort of the next numerical value. Clustering is trying to find similar types together of whatever it is. And classification is more like yes, no, good, bad, yellow, green, dog, Labrador, fried chicken. So it's more like a yes or no answer. So that was my crash course on AI machine learning. I hope, no engineers have walked out the room, so that's great. So now we're like, wow, that all sounds really, cool and vague and interesting, but what can we do with that? So a few common applications or places you might have seen machine learning already. There's not so much interaction, so we'll do that part later. So the OG of machine learning is spam filters. Basically, that's like the original example kind of classification, where it's like, does this email seem suspicious or not? And it looks at a bunch of variables. And again, it learns over time. So if it serves you something in your inbox, and then you have to manually tell it it's spam, it iterates on its parameters for next time, so it becomes more accurate at predicting spam or not. Or also if something goes in spam and you have to say like, no, no, it's not spam. This is like my grandma's email. Why did you? You know, and then it tries to learn from that over time. So spam filters. AlphaGo, do people know AlphaGo? No, yeah. Okay, so like in the 90s, Deep Blue was this like machine learning chess player, and it beat the world champion of chess. And at the time, people were like, oh, wow, AI, but also chess is a very strategic, logical, almost computational game. So it kind of makes sense that a computer would be really good at it. But then a few years ago, I can't remember exactly when, like 2015 or something, Google, DeepMind, which was then acquired by Google, built this model that was basically able to play Go, which is an ancient Chinese game that everybody claims is super intuitive and super human, and like there's no sort of logic to it, and you just have to like feel it out. And I don't know, everybody was convinced that a computer would never learn this, and then it did, and then it beat, the world champion of Go. So this was a very interesting kind of recent moment in developments of machine learning, and it did reach a lot of the general population. And started getting people to think about that. Lots of interesting things around this, like Move 37 if you're a super nerd, but not going to go into that for now. Then really obvious example like Discover Weekly on Spotify, like the curated playlists that are perfectly tailored to your music taste. I really love these. I'm an avid user of these, but also I think it's really interesting how they work. So for example, a lot of the music recommenders in the past, they would have been built on metadata. It's like, oh, you listen to hip hop, we give you more songs that are tagged hip hop, right? Or like basically like that, like, oh, you listen to this artist, we give you more of that artist. This one works very different. The algorithm basically works with clustering, so those little dots of similar groups of things. And so it kind of just looks at like, okay, you have sort of this music taste. This person that has nothing in common with you at all has a similar music taste, and then they basically start serving you songs from their personal library, which is really interesting. So it's almost like a crowdsourced like music curation. And it also completely surpasses all this like demographic stuff, which I think really doesn't apply anymore in this day and age of, you're this gender, this age, and you live there, so you're this kind of person. And it's really deeply personalized. So great example. Also just, great playlist of music every Monday morning, so shout out. So when we look at machine learning applications, mostly people group them according to like technical capabilities. I'm a designer, so I don't do that. I mostly group them in my head according to like user value or user experiences. And that's how we're going to talk about them today, sort of in that framework. So one sort of new user experience that AI is enabling is smart things and post-pixel interfaces. So in the past, computers were literally like limited to these tiny screens, right? First it was, okay, desktop, and then it became this tiny thing, but it still just lives within a screen. Like it's very limited, and I have to tap on it, which is actually really annoying. So now with a bunch of like machine learning applications, we can have things like speech and gesture interface and spatial computing, where computing is actually integrated into the physical world, and we can interact with it in different ways that are not tapping on a screen. I'm quite excited about this one, if you can tell. So a few quick examples are like autonomous vehicles, things like Internet of Things, so like smart, home appliances, so like the Nest sort of temperature control, or like the smart doorbell. I love this example because the computer vision, like the facial recognition, kind of messed up and thought Batman was at the door. Just like a cute AI fail. I love cute AI fails. Then another one, and there's many more of these, say like Roomba or anything that generally works with sensors, like sort of IoT related, but also speech interfaces, so like voice assistants, gesture interfaces, which they're working on, where which is combined with VR, AR, but where you can, sort of project screens and just do like this, or you already have them where you have the laptop, but you can interact with it like this, so I don't actually have to make kinetic contact with the thing. They're using those in medical hospitals, for example, for doctors that are doing operations, and they're using computers. That's kind of nasty if they have to be inside your guts and then tap on the screen. So most of those now have gesture-based interfaces where a little camera recognizes the gesture you're making, whatever that is, and then does a certain action based on that. This one is affective, so it's kind of like emotional AI, a lot of people call it. So it means that it's able to detect and respond or even imitate emotions. This one isn't widely implemented yet because there's a lot of sort of complications around it. So some applications where like Walmart was, tracking people's moods live and then kind of sending them, target advertising or even like shuffling around the store based on how you feel. So like if I'm having a really bad day, they'll target me with Ben & Jerry's and I'll become fat. Like that's not really nice. So there's a lot of complications and people have a lot of concerns, rightful concerns around their privacy when their moods and emotions are being detected and acted upon. So this one's a bit tricky, but I think it is really interesting to think about like the meaningful and helpful applications this could also enable. So it's a bit in voice assistant. So for example, if I get really pissed off with my Google Home and I say something that's not so nice, it will respond to me in a different way than if I speak to it in a sort of like cute voice, like, oh, thank you so much. Or I'm just like, oh, thank you. It will give me a different response. And I just started noticing that recently, and I thought that was interesting. But yeah, there isn't so much applications of those yet. This one we're mostly familiar with. It's depersonalization. So it's everything from Spotify and targeted ads and Cambridge Analytica, all that. But it's also, for example, Netflix has started experimenting with this, which is not only tailoring the recommendations to you. So like we think you would like this, this, and this film, but it's also tailoring the thumbnails of those recommendations to you. So for example, if you watch a lot of romantic comedies, no judgment, it will give you for Good Will Hunting this like cute thumbnail with Skylar, in which they're kind of hitting it off. Whereas if you're watching a bunch of just comedies and funny stuff, it will give you the Robin Williams thumbnail. And so that one is more based on genre. And then they're also doing it with actors. So whether you get Uma Thurman or John Travolta for Pulp Fiction, and even like the font is different. And like they're currently experimenting with this, and apparently it's really it's very much working. Like just adapting the thumbnail to what works for people and what kind of triggers them. So that's an interesting one. Context awareness is more about actually understanding, like actually our technology currently is really quite dumb, I think. And this one is really understanding like where your user is currently and what their context is and how their context might influence their needs or their behaviors differently. And so their context isn't just like your phone is on or off or on disturb or like on non-disturb or that. But it's like, what is the location? Who are you with? What are you currently doing? And how do all those things maybe influence what you need at the moment or which applications you might use or how you might use them? So things like that. So there's this one, which I quite like, Google Lens. It should be on your phone already, actually, if you have an Android. Where basically in the camera itself, you can point it up at anything in the world, kind of, and it will feed you back what that is. So it could be at ads, or it could be at products, but it could also be at like cultural landmarks or art in a museum, and it will tell you everything about that art piece. So that's really cool. And then, not so many applications of that yet. Also, I think we can think of a lot more. Most of these have a lot of imaginary applications in my head, but it's hard to find the examples in the real world. Also more cute dogs, because I figured I'll keep the theme going. Anticipatory and agentive tech is also a really interesting one. So anticipatory is more around predicting what you want before you're going to ask for it. So great example, actually, the other day I was interacting with my Google Home, and I asked it to play Gold Link. I don't know if anybody knows Gold Link, great music. But I asked it to play Gold Link, and then it told me, yes, okay, we'll play Gold Link on Spotify. Also, he's doing a show in Amsterdam on blah, blah, blah of November. And I was like, I didn't ask for that, but that's great to know, because it knows I love this artist, and it knows I live in Amsterdam, and so it is proactive about giving me this bit of information, assuming that it's something that is relevant to me. So I thought that was an interesting bit of being proactive rather than reactive, which technology has always been only reactive. And agentive is also about technology acting on our behalf. So again, Roomba is a great example of that, where we no longer have to interact with the tool to get something done. So like technology, we've always used tech or tools or whatever you want to call it to make things easier, right? To get a job done. So say we want clean floors. First we were just going like this, and then we made a broom, and we were like, oh, that's much more practical. Now we can broom it. And then we're like, this is still kind of annoying. We have electricity now. Let's make a vacuum. And then we've reached the point where we're like, I don't even want to touch this vacuum at all. I just want the floor clean when I get home from work, right? With Roomba or like any robotic vacuum. Sorry for all the, non-ad ads. But yeah, so it's really interesting, because now I have the outcome of a clean floor without having to interact with the tool or the technology at all. And that quite changes our relationship to technology. So that one is really interesting. Amazon has patented this thing, which is called anticipatory shipping, where basically they ship something to a warehouse closer to your house if they think you're going to order it. So they know when I last ordered my Post-its. They know sort of how many Post-its I ordered, because, I make repeat orders. And so they will already start moving these Post-its closer to a warehouse, closer to my house when they think I'm going to order it. Or like a new book has come out of your favorite author, they're going to already bring it there. So they are literally predicting your next purchase, and then, making their supply chain more efficient because of it. And they wouldn't do this if you wouldn't actually go on to buy that thing. So they know what you're buying next, which is pretty crazy to think about. And then there's all the Backstage stuff, so stuff that improves the user experience, but they don't necessarily know that it's like machine learning in the back end. These are actually most applications where, not necessarily anything changes for the user so much. The thing just works better, faster, cheaper, more efficient. I'm very interested in the more user-facing, interfacing stuff, but these are, very valuable as well. So one that's, actually this one is also predictive. Most interesting AI applications don't fit into one of these categories, but like 2, 3, or maybe 4. But just for, frameworking, I've tried to kind of take them apart. So IBM now has an algorithm that can predict with like 95 accuracy whether you are going to quit your job in the next few months at IBM. And they've started, acting on that. And so when your score goes up and you're ending in this sort of high risk might leave zone, and you're someone that they really don't want to leave, they'll come and have a conversation with you and see what they can do, what you need, what they can offer you to make you stay. Or if, sometimes there's a mistake and it's something outside of their control that, makes you want to quit, like your spouse is moving to a different country and you're moving with them or whatever. But often it will be something that they can do something about. And this is active. It's 95% accurate, and it's saving them obviously a shitloads of money at HR. So it's quite interesting. And then, things like this. There's a lot of medical applications where similar to the Labradoodle and the fried chicken, but much more useful. They've trained models on recognizing different skin diseases or early signs of skin cancer. And so it's used for doctors to kind of support their diagnosis, and sometimes they're even brought into these user applications where obviously it cannot make a real diagnosis, but it can, give you an indication of whether you should be worried or not. So yeah, how do I see opportunities for innovation with AI? So quote, because I'm not the only one working on this. But yeah, basically there has been a lot of progress and like a lot of advancements in machine learning, and all the reasons for that, like the amount of data we could produce and access to computational power, and just like this community of machine learning engineers growing. But I feel like it should be accompanied by a design revolution. So design innovation with this material is kind of lagging behind the material advancing. So like researchers are doing really great things and inventing all these models and tweaking all these parameters and making stuff really work. But sometimes I feel like this happens in a silo and it doesn't always reach, users or like people or the population, and we don't always have the people involved in those places to think of how these things might actually help people. So I would love to, see those things come more together so that we can use all this amazing technological advancement, not just for targeted advertising or the military or, things like that, but for, more interesting, meaningful applications for people. Why is this important that you get involved with AI, especially if you're, not an engineer, or maybe this is also the slide, like if you're an engineer, this is why it's important to let other people get involved as well, or actively try to engage them. Turn all this advancement in technological capabilities into like real value for real people, but also knowing what materials available to us to sort of solve the really complex things in the world today, like the really, really grand scheme problems. And then also in general, like democratizing access and including everyone in the conversation, because this is going to happen whether we want it or not. This is not like, oh, is machine learning going to progress further? It is, the train is leaving, are you getting on it or not? Like that's basically it. And I think it's really important that while all this stuff is happening and coming into, every area of our lives over the next few years to come, it's really important that it's not just at the table, but there's, business people and sociologists and philosophers and artists and God knows who, like, a construction worker. Like everyone should be able to at least conceptually be involved in that conversation and think about what the role of, these sort of algorithmic systems is going to be, and not just, keep it in a silo. This is my sort of aspiration to like bridge AI and design being not just very much actually not graphic or visual design, but like anyone that considers themselves involved in like creating new products and services and systems that ultimately affect people. Congratulations, or I'm sorry, but you're now considered a designer. Then also I think from a more design perspective, it is actually the next sort of big leap. So in the industrial era, designers made products. In the surface era or surface economy, surface design became a thing. Then experience economy became a thing. With that experience design, right, very much like multi-sensory and stuff. I saw there's an exhibition happening right here, or promo for like a multi-sensory exhibition right here in the city. And I think as we're moving into like a digital or computational or algorithmic, I don't know what the hell we'll call this next thing, but into that economy, what we're designers are going to be designing are these systems. Today I'd like to sort of collectively imagine and maybe even go on to manifest value of AI in, different applications depending on what's your context, what you do, and how you want to help your users or whatever role you want to play in people's lives. So a lot of people are like, oh yeah, machine learning, that sounds really big and complex. I mean, to the engineers, you're like, yeah, I can do it. But most people, designers and such, it seems like a really far away thing that's happening at Google and IBM, and it's not accessible to us. But yeah, I'm here to tell you that you don't have to be a tech giant to use AI, although you might have to work with them and use their services. So if we're looking at machine learning ingredients, very simply, it's like data, algorithms, computational power. If you have these three things, you're pretty good. But also, you need a damn purpose. Right? And this is the part that I feel like sometimes it's missing and why we're here. So this part, nobody can really help you with. This part, you'll really have to figure out yourself. But there is building blocks for all the other stuff. So for example, with data, there's lots of, you can look at what data do you own or what data do you have access to from your partners. So yeah, most people do know sort of machine learning runs on data. Like a car runs on fuel. You can have a car, but without fuel in it, it's pretty useless. Yeah, machine learning is like that. Without data, you can't feed it anything. It can't do anything for you. So data can be one place to start with that. So you can look at what data do you have, but often people are just like, we don't really have data. Machine learning is not for us. The end. But actually, there's lots of public open data sets. Obviously, there's, not everyone's just giving out their free data, but surprisingly, a lot of people are actually giving out free, labeled, structured, interesting, big data sets. So a great place, I have a few resources here, so you can take a picture. Or, I will send this to you later as well, so don't worry about, taking compulsive pictures. Everything will come to you afterward. But there is lots of open data sets out there as well. So you could look at who are we serving, with what problem, or what industry do we kind of operate in, and what kind of data sets, open data sets, are available around those topics. And then, start from there. And then there's also how might you creatively acquire labeled data. So for example, how sometimes nowadays with CAPTCHA, CAPTCHA was also that. It was basically training a machine learning model to recognize handwritten digits. But now you also have this one where sometimes it says, click all the pictures that have a street sign. Have we seen this? Like you're trying to post a comment or something, and it's like, please confirm you're not a robot. Take all the screen signs. Besides validating that you're not a robot, you're also now training the model about what a street sign looks like, which is so smart because you're solving this, systems problem of having to validate that people are humans so they don't freaking spam your entire website. But at the same time, you are all, crowdsourcing basically and labeling this data. And there's lots of examples. Duolingo works like this. CAPTCHA works like this. And there's a few more interesting examples of those. I didn't know this. I just found out about this last year. I was like, oh my God, I've been training these models for free the whole time. Insane. But yeah, we are also benefiting from them, so it's fair. So yeah, that much for data. And some, different ways to think about acquiring it than just, we don't have it. Then there's machine learning building blocks. So yes, you can code and engineer it. These are, some of the languages often used. But there is lots of building blocks that we can build on. So this is either something you can communicate with your engineers, or it's something you can go out and learn if you're feeling, kind of experimental and ambitious about building up your computational skills. So sort of ranging from level of technical expertise. Yes, you can build a custom model and code it. You can do that. Then you can use libraries, right? So kind of like open source code that's out there that works really well, and you can build on best practices from other people. There is also sort of graphical user interfaces that's slowly coming along. So you can interact with it in a slightly more intuitive way. And then these are literally surfaces where you almost don't have to do anything technical. A little bit, but not that much. And this is really the easiest one. If you're like, I am never going to learn machine learning and I have absolutely no interest in any sort of coding, you're here, but you can still do a lot of stuff, like in your browser or just in web apps that are free, and you can download them and you can use them almost with the same ease you would use something like Facebook or Instagram. So these are really cool. Again, I can send this to you later. And there's also Runway ML, which is currently my favorite program, but yeah. It's more like for artist stuff. And then there's computational power, and obviously like the cloud. So cloud GPIs are everywhere. You can just buy computational power of Amazon or Google services. If you're a startup, they actually give like $500 or something of computational power to you for free. So this is not, no longer sort of a barrier in that neither. It's quite cheap as well if you're not, running a crazy model. A lot of people I know that are engineers, they still have like a bunch of desktops at home, and they just train their models on that in this like really stereotypical hacker kind of looking room. Can also do that if you want to look interesting. But yeah, you can also just toss it onto the cloud and run it somewhere else. So these things are available to us. There's building blocks out there that we can work with as, non-engineers. But then there is the damn purpose part that we cannot just grab from somewhere. AI will not tell us it can do a lot of things, but it will not tell us problems worth solving, questions worth asking, or inefficiencies worth preserving. Again, it will just make things efficient and practical and rational, which doesn't always map onto our, sort of subjective reality. So this part is a human task. This part, up to us. We're going to have to still do this.